We have a polynomial given as a product of three linear factors. We want to graph the polynomial. We begin by finding the intercepts. Y-intercept occurs when x equals 0. Y equals f of x. F of 0 is 0 minus 3, 0 minus 1, 0 plus 4. That multiplies out to 12. So we know the point 0, 12 lies on the graph. X-intercepts. X-intercepts occur when y equals 0, y equals f of x, so f of x is going to be 0, so this product is going to be 0. So we have x minus 3 times x minus 1 times x plus 4 equals 0. This is only possible if one of these factors is 0. Any one of them could be 0. Only one can be 0 since, of course, the factors are going to give you different results for any given number. So either x minus 3 can be 0, or x minus 1 can be 0, or x plus 4 can be 0, meaning x could be 3, 1, or negative 4. And at no other point can this product be 0, because any other number is going to give you non-zero results for all three factors, and when you multiply three numbers that aren't 0, you don't get 0. So we know now that the graph goes through negative 4, 0, corresponding to the x equals negative 4, through 1, 0, corresponding to the x equals 1, and through 3, 0, corresponding to the x equals 3. Now we don't know how the graph goes through these points, but it has to go through all four of these points. Okay, it could come down like so, just touch this point, so it's 0 at this point, but it doesn't go through the axis. It could go back up here, for example, then it could turn around and come back down, go through the axis. It could come back up here and come down here. Alternatively, it could start from down here, come up through this axis, come up here, come down to here, come down here someplace, and then come up here and go on up. There are other possibilities. I find a different colored chalk. Could come up, well, now it can't do this. It can't turn around at this point, because if it did, it would not be able to get up to 0, 12, because the only place the function can be 0 is at these points. If it turned around and tried to come back up through here, it would be 0 at another point. So that's not going to work. That can't happen. So it has to come up through here. It could come up something like this one does. It doesn't have to have its peak at this point. It could turn around somewhere else, come back down here, turn around here, come back here, and go down this way. So there are all kinds of ways we could go through these points, and we have to determine which way actually happens. Well, we use the fact that the only place the function can change its sign is at one of the zeros, because the graph, in order to go from negative to positive, it has to go through the x-axis. If it's going to go through the x-axis, it can only do that at this point, or this point. Because as I said, if there was another point where we went through the x-axis, there would be another 0, and we can tell by these factors that there is no other point that will give us 0. So we determined that f of x has the same sign from all the way from negative infinity up to negative 4, from negative 4 to 1, from 1 to 3, and from 3 on to infinity. We can easily figure out what the sign will be. We already can see what the sign has to be between negative 4 and 1, because we have this point here above the axis. When x equals 0, y equals 12. So that everywhere from negative 4 to 1, x has to be positive. Since it's positive here, it can't get through the axis to go negative until it gets to here. Then it's stuck. It's got to be positive all the way. It's 0 here, positive all the way from negative 4 to 1, except at those 2 points. So if we want to know what the sign is from negative infinity to negative 4, we just choose any x value in the interval from negative infinity to negative 4. Somebody wanted to choose x equals -5. Well, evaluating the function at -5, which you can easily do, we get -48, meaning that the graph is negative all the way from x equals -infinity to -4. The graph is below the axis. So it's going to probably have some behavior that looks something like this. Up to this point, we don't know that it does this beyond the point, but we know it's going to have some behavior. It could do this, come down here, then it could come up and go down as far as we know. So it could follow the red graph. It could follow the white graph, which is very much like the red graph here. Okay, well, in the interval -4 to 1, we could choose x equals 0, but of course we've already essentially done that when we found the y-intercept to be 12. But if we choose x equals 0 and evaluate it, we do get 12, and that confirms that the function then is positive for that whole interval. On the interval from 1 to 3, well, the easiest number to use is an integer, and the only integer we've got between 1 and 3 is 2. If we let x equal 2, we get a positive number, and you can verify that for yourself. This is going to be negative. This is going to, I'm sorry, we get a negative number. 2 minus 3 is negative. 2 minus 1 and x, 2 plus 4 are both positive. On the last interval, we use x equal 100. Why do we use x equal 100? Well, we want to know what happens when we get out there a ways, as well as whether it's positive or negative. Also, choosing x equals 100, 100 is bigger than the absolute value of any of these zeros. So, and it's a lot bigger, so it's going to give us some additional information. In addition, it's going to be obvious whether it's positive or negative. Well, if x is 100, then these numbers are 97, 99, and 104, and you don't even have to calculate these numbers to know that they're all close to 100, so their product is close to 1,000,000. Okay, so we know if we go out there 100, we got to go up 1,000,000. That's a long ways up. But we do know that about the graph.